All right, so a quick review of playing with percentages. And a couple things to remember. The word percent literally means divide by 100, and that symbol is a shorthand for divide by 100. And so anytime we have that percent symbol, like suppose we had 45%, we can just replace the symbol with what it really means, which is divide by 100. And then from there, we could either call it a decimal or leave it as a fraction. If it's a fraction, we might care to reduce it. In this case, I could divide top and bottom by 5. 5 goes into 45 9 times, 5 goes into 100 20 times. So 45% could be viewed as 9/20ths or 45/100ths, which is pretty much what the percent notation means anyway. We're going to look at a percent decrease problem here with a graphic to help solve it. So let's suppose there is a 45% off sale. And we see that the sale price of, let's say, a book we want is $33. And my question would be, what was the original price? And so first, I'll solve this using a graphic, and then I'll set up a proportion to solve it. So the way I approached solving this with a graphic the other day was to make a demonstration of what 100% meant, and then break it into related chunks. Since this percentage is a multiple of 5, then I would choose to break up my 100% into chunks of 5. So let's see, starting over here, that can be 10%, 20, 30, 40, 50, note, 60, 70, 80, 90, 100. And the drawings that we make for these fractions and percents and decimals, they really should be to scale. So you need some kind of a number line, whether you use graph paper to do that or a ruler is up to you. So this right here is my 100%. With a percent off, I'm taking from 100%, 45% off. So if I back off 45%, that'd be 10, 20, 30, 40, 45% off would be right here. So if I have 45% off, that means I pay 55%. Clean this up a little bit. So this right here represents my 45% off, which leaves me paying 55%. And that 55% I pay is the same thing as the $33. So I'm going to put that above. So this mark right here is 55% or $33. Now, important thing to note here, anytime we have a percent increase or decrease, that's always based on 100% as the starting point. So if we have 100% to start with, and we take 45% off, right, that's where that 55% comes from, which graphically makes a lot of sense, I think, because we can see the 55 and the 45 together. The $33 is the sale price, so that has to go with the percent that we pay, the 55%. Not the 45%. We weren't given the amount off. We were just given the amount to pay here. Another thing to note here. 100% is 20 groups of 5%. So sometimes we break up our percent into 5%. Before we had a 10 by 10 grid where we were breaking it into 1% chunks. In a previous example, we viewed 100% as 10 groups of 10%. So there's a lot of different ways we can go about doing this, depending on the percents that we're given. So we could do 100 times 1%. And that was the 10 by 10 grid version we were looking at before. If I'm looking at this in chunks of 5%, then I want to think about how many groups of 5% make up 55%. we should realize there are 11 groups. 11 times 5 is 55. Well, that's the same thing. Oops, I labeled that 35%. That's $33. Let's fix that. That $33 is all of these chunks here. So if I have 11 chunks of the same size and the result is $33, that means each of these must be worth $3. And you don't really need to label all of them, but I'm just trying to make sure that point is clear here. Now, I would really like to know what the thing was worth originally. Well, every 5% chunk is worth another $3. So I can either count up by 3 to get there, or just remember that there are 20 groups of 5% here. So there's 20 boxes. So this has got to be 20 times 3, because each box is worth $3. So this thing should have been worth $60. So the original cost must have been $60. And we can double check that by just taking $60 times 55%. So calculator, if you don't have one. That one, scientific version, since we don't need to graph. So $60 is what I think the starting price was. If I take 45% off, that means I pay 55%, and that should lead to the $33 that we had before. So for the activity, what I'm hoping is that for each problem I give you, that you're going to have an image created, and that image is either going to be in groups of 5% or in groups of 10%, depending on what the percent was given, and then you should be using that image to come up with the answer. And then we can check the answer after. So this does check to be $33. So if one of my questions was, we have a percent off of 45% and the sale price is $33, what was the original price? Then this is what my work would look like for that. So I can finish it off, the original price. $60. If the percent off is 45%. Another way to solve this besides the picture, and again, the focus of this activity is drawing these pictures. Pictures should be drawn to scale. So if your pictures aren't to scale, you might want to redraw them. We can always use a proportion to solve these percent problems. Now, in this case, I have to consider the things I'm interested in. Let's see, I have the sale price. That was the $33. And I want the original price. So that's what I'm missing here. To relate the sale price and the original price, I need to know what percent I pay. So as far as percentages, the original price is always going to be 100%. The sale price is related to 100 minus 45, which was that 55. And if you don't get to that 55% first, you cannot solve this with a proportion. So then my proportion would look like this: original over sale. You could do sale over original if you want. The reason I put original on the top is because that's the missing number, and proportions tend to be easier to solve if the missing number is in the top. So the original price is unknown. That goes with $33. The original percent is always 100%. And then the sale percent is actually 55%. Now, I don't really need the percent symbols here, and I could put in decimals instead, but it turns out it doesn't matter either way. So then this would be the proportion I want to solve. So to solve this one right here, since I have the missing number in the top, all I need to do is multiply the 30 to the other side. And so question mark, my missing number has to be 100 times 33 over 55. Now, this is a process that makes sense if you think through it. The picture really shows the breakdown of how the percent are related to the numbers. And so when we make those pictures, I'll redraw that again because it got a little messy. There we go. Again, you have to have some kind of scale. So if you're not using graph paper, so if I didn't have that background as a graph here, I just had plain paper, I need some way to mark off an equal number of equally long pieces. So you can either kind of eyeball it or get a piece of paper down with lines to try and make yourself a scale. So I'm going to attempt to eyeball 10, 20, 30, and I need these to be equally spaced for my graphic to make sense. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100% went in there. So if you don't have graph paper, you're going to have to find a way to make it as uniform as possible. So this is my 100% down here. I got to take the 45% off. So that would be back 10, 20, 30, 45%. Hopefully I counted this out right. So this way it should be 10, 20, 30, 40, 55%. So there is my 55% that I'm paying. Could make a note to myself that that's a 10% mark there. And that also matches the $33. Why do I keep writing a percent sign? Now, since I'm really looking at a 5% cutoff, then I think it makes sense to split this up into 5% chunks. Just makes the graph paper nice, so I don't have to draw all these lines. So I'm having trouble drawing on my fancy tablet here. I'm a little better. These should all be roughly the same width. To the best of my artistic ability on this tablet today. So there are my 20 chunks. I might even put a reminder myself. 100% is 20 groups of 5%. I have from here to here 11 groups. As percentages, each of those groups is 5%. But I could also take that $33, split it into 11 groups, and see that each group is also worth $3. So that my original price here has to be 20 groups of $3 or $60. Right, so that's the process in setting up these pictures. With the kids, the picture would be partially drawn out for them and they'd have to fill it out. You guys get to draw the pictures from scratch on your own. Graph paper helps be a little neater. Otherwise, you have to find a way to be neat and proportional when you make your picture. All right, so what I want to do right now is give you guys a few minutes to compare answers on your percent problems here. So I think I'll do about 10 minutes for you to compare answers on these 5 here. And again, if you have pictures to share with each other, cool. Otherwise, just talk about your pictures and see if you can come to some agreement on what the pictures should look like and what the answers are to those.